So today we are going to add another type of graphing to our list, but I wouldn't say it's a new type of graphing, it's a new type of equation when we're graphing. So today we're going to look at graphing inequalities. And hopefully that sounds familiar. Why should that sound familiar? Because we've already done it before. So remember, what I write over here on this sideboard, you don't need to write down in your notes. We're just getting our brains sort of thinking here. Can you please close that and put that away for me?
Oh, sorry.
So last trimester, we talked about something like x is greater than 2. If we had something like x is greater than 2, how did we graph this? Okay, so we had a number line. And what did we put on our number line? 1, 2, and 3. And then what?
So we'd be going this way with an open circle.
Okay, why? Why did we do that? Caleb?
So we did an open circle because it doesn't have the line at the bottom of it, and it's pointing to the right.
Okay, so you are telling me very true statements, Caleb. And I think most of the students would agree. But you're telling me the rule, right? That's the rule we were given. Why is that the rule? I mean, it is correct, that is the rule, but why? Why is the rule the way it is?
Wait, my bad. I just forgot the question.
It's okay. Why am I putting an open circle here and shading to the right?
Because
other than that's just the rule we were told for that symbol. Jonathan?
Because not like a negative. If it wasn't negative, it would be to the left, I guess. I don't know.
And why don't those values work?
Because that's how they made them.
Chloe?
It's not including 2.
Okay, so it's open. It's open because is 2 an answer?
Yes. No.
No. No, right? 2 is not an answer. It says x is greater than 2. It can't actually be 2. So what's the first number greater than 2?
3.
How about 2.5?
Yes.
How about 2.1?
Yes.
How about 2.01?
Yes.
How about 2.001?
Yes.
How about 2.0001?
Yes.
2.00001? How long could we do this game? For forever. Can we write down the first number that is larger than 2?
Yes.
No.
No.
Right? It's 2.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 you could say a couple more zeros and they would be closer. So that open circle means we can tiptoe up to 2 as close as we want. We just can't actually be 2.
We can't land on it.
Right, as soon as we land on 2, we fall through the ground.
Wow.
Okay? All of this space over here that's shaded represents then what? All the other answers that do work. Because how many answers are there?
A lot.
More than a lot.
Infinite.
Infinite. Okay, so we have to be really careful with this. Okay, I'm pretty picky on my students with this one. Right outside the door. Right outside the door. There's a bottle one right outside the door. We have to be really careful with infinity and infinite. Okay, infinity is like a location on the number line. It is a number. Okay, infinite is like an adjective. It describes how many there are. So there are an infinite number of solutions. Okay, that means if I said, Caleb, tonight your homework is to write down every single number that's greater than 2.
That's a lot.
Okay, yeah, Caleb would go, no thanks. I couldn't do that. I'd be writing for forever. So instead, since we can't write them all down, we represent what they all look like. Same idea needs to happen today, except now we're going to be graphing on the coordinate plane with inequalities. So we will have 2 variables. We will have an x and a y. Okay, and they will look like lines. Instead of like we're just being on a number line, we will be on our X and Y axis. So the rules are very similar, but they change just a little bit because we're no longer dealing with just a single number line. So our rules, again, like I said, very similar, slightly different. Say if we have greater than or less than, we can't use an open circle because we're looking at lines. So if we have greater than or less than, instead of using an open circle, we will use an open line, but an open line is going to be a dashed line.
Wouldn't that be a closed dash line?
Right, so a closed line is just going to be a solid line. And the reasoning is the exact same reason we talked about over here. That open circle, just like the dashed line, is going to say we can get as close to it as we want. We just can't actually be on it. If we are greater than or equal to, right, before we would shade to the right, but we don't have that situation here. It's not like right or left when we're talking about all directions of a coordinate plane. So we are going to shade above. Does it make sense to us that numbers that are larger would be above in the sense of a coordinate plane? Okay, and if it is less than or equal to, we are going to shade below. So sort of the memorization trick, if you like those sort of catchy things, less than is lower, less than is to the left. We can no longer think of these as arrows pointing because above and below will depend on the angle of the line. Now, this does still come with a sort of catch. When we were using these rules for graphing on the number line, we could only use those rules if the variable was first. So when we're graphing on the coordinate plane, we can only use these rules if it's solved for y. Now, I am not going to lie or pretend this doesn't exist. There are ways to graph and get the correct shading without solving for y. It's kind of a long and not super fun process, so we're just going to stick to this one. In your textbook, or if you were to Google it, you would see lots of reasonings about how to sort of find that shading in other forms. We have found it's way easier to teach our students to solve for y, since that's something we've been doing for forever, than it is to do all of the extra math behind it to graph in the other forms. Okay? Now, if we know this list, and we know how to graph in the y equals mx plus b form, everything else pretty much just falls in place today. Not a whole lot of new information after that. So let's say we want to graph the inequality y is greater than 2/3 x minus 4. Okay, when we go to graph this, the first thing is that we just want to make sure this is in the correct form. The form says that it has to be solved for y. So is this inequality solved for y?
Yes.
Yes, this is in y equals mx plus b form. So check, we're good there. The second thing says that we want to think about this just like we would think about y equals mx plus b. So forget the fact that there's an inequality sign right now. And just consider slope-intercept form. So what does m equal? 2/3. And what does b equal?
-4.
-4. And we're going to graph by the rules that we already know. So where are we going to start?
-4.
-4.
Then we're gonna go up.
Exactly.
Yes.
Okay, and then we're going to consider our slope. We're going to go up 2 over 3. Now, I don't want to say this is a requirement because I don't want you to be like, oh my gosh, you're doing it wrong, you don't have it. Today is a really good day to start some very good habits that are going to be really important when we get to systems later in the trimester. And that good habit means a long, clear line across the grid. Yes, Isaac?
Should we have to draw the graph?
Do what?
We have to draw the graph.
We're going to have to, but we want to make sure we get some good points. So I would suggest that you are being pretty detailed and giving yourself a few extra points to make sure you're getting a nice line across your graph. Because it is going to be important later that this line is for sure clearly all the way across the graph. I'm not going to count you wrong if you're a little bit short, but you are going to be much happier to start those habits now. Okay, now, this is how we would normally graph, correct? And do we agree that this is y equals 2/3 x minus 4?
Yes.
Now we need to consider the fact that we're not talking about y equals 2/3 x minus 4. What does our inequality really say?
Y equals MHSB.
Y is greater than 2/3 x minus 4. So what new rules do we need to consider? Okay, so greater than tells us to do what?
Dash line.
A dash line. So now instead of just sticking with this regular equation, we now want to consider that's not what I want.
Oh, is this where you like make short
A
intervals?
dash line.
Yeah.
Okay, so we want our line to be dashed. What does that dash line mean?
The points that are
No, the points that are
in between it, right?
what you call it, that is open.
So when it's an open circle, is that actually an answer?
No.
No. So far we actually haven't put down anything that's actually an answer. This is the point, the line in this situation, that we can get as close to as we want. We just can't actually stand on it. Yes, Caleb?
So those are the points that we're not supposed to land.
Yeah, this is sort of our border.
Those are the others.
This is the fence. Okay? Now we need to consider which side of the fence we need to be on. So we need to decide,
The one on the
are
top
we going to
is
shade
greater.
above or are we going to shade below?
Above.
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 Okay.
Greater.
So we need to shade above, but here's what you need to consider. Some of my students look at this and no problem, they easily see above and below. If you do not easily see above and below, you can blame your parents. It's called spatial reasoning, okay? Children who spend less time playing with like blocks or like building things and stuff like that. Spatial reasoning, sometimes we still need to develop, that's okay. If you have a hard time seeing it, I tell my students to imagine a bug, always picture a bug walking uphill. So here's my bug, there's its antenna. Picture it walking uphill. Okay, the stuff above is the sky, the stuff below is the dirt. So we want above, and we want to start good habits with shading as well. So yes, that is showing that you want above, but that is going to be a really bad habit to start. So don't shade that little. Don't also write down the next thing I'm about to write. This is the next thing my students might consider.
Oh, you don't want to do this.
I mean, yes, that is shading above, but that is too much shading above.
Can't you just do one and be square?
We need a happy medium. So my suggestion
Shade above -4.
is shading like this,
Oh.
where you're doing everything above, not too dark, not too light, not too much, not too little.
Just in between.
A happy medium in between. That we still see what's above, but we still have some room to do more with it.
Just like this.
And I would even suggest Making sure you're giving yourself the enough, right? Make this line super long so that you're giving the other space.
Miss
So
McKinney.
it won't be wrong, but it'll be important later.
Wouldn't this work too?
I mean, you're really going to want to give more up above so we see that whole thing. It'll be important later. I wouldn't count that wrong on a test.
So instead of the line I did, extend it.
Yes.
Okay.
Yep, that's going to be a good habit we would start. Yes, Isaac. Yep. Yep.
Thank you for the tips.
Yeah, it's just, like I said, I'm not going to count you wrong. It's just going to be helpful later.
Okay.
When we get to later material, it'll be important that we have good shading. You'll be happy later when it's already a habit. Okay, so let's look at I want to look at a couple more situations here, and we'll move on to some practice. Pen. What do we think about this one?
Not so.
Wouldn't you grab that to 0?
Can we solve this for y?
Yes.
Well, no, there's no y at all. Okay, that's a dilemma. Okay, so skip that because we don't know what to do. There's no y involved. So let's see if we can get a graph at all. So if we graph this, thoughts about how we want to graph this?
Well, the x would be.
Oh, wouldn't you graph it at the -2 of x?
The x what? What's that thing called? On the x-axis, which is the x-intercept.
X-intercept.
Okay, so we have an x-intercept of -2. Okay, I'm good with that point. I agree.
And you're still 0, but you have to still make it a fraction and put the 1 under the 0.
Y is not a 1. That's a good thought, but it's not.
Oh no, the y is 0, but
The y is not a 0.
Wouldn't it?
That is also a good thought, but it's not.
Wouldn't it be
Caleb?
-2? 'Cause,
Nope.
uh,
What is the y-intercept on this one?
nothing.
Nothing. It's undefined. There's no y-intercept.
The line's just.
Okay, so if we want to graph a line that does not touch the y-axis, we need a vertical line,
Yeah, it's just straight. It's just a straight.
right? Straight up and down because it can't touch the y-axis. Solid or dash line?
Solid.
Solid
Because it's closed.
because it's or equal to, right? It's that closed concept.
And it's less than, so you graph it.
Which way? If we think less than, above or below, there's no above or below here. So which way do we think below is going to be?
Down.
Under the negative, or under the.
Is there something to go under? My line's here.
We're gonna want to do it to the left and see. Wouldn't it be like this?
Why?
Because it's. Wait. No, the sign would change. Wouldn't it?
No?
No. Well, it's.
Wouldn't it be on the
negative, so-
right? Because.
To the left is the correct direction.
It's because it's negative.
No?
I know for some reason I know it's to the left. But. Oh, it's 'cause
Why?
Oh.
The sign's.
We want to fall back on our old
The
rules,
sign.
right? Less than is left, but what numbers are less than -2? -3, -4, which are all of these numbers over
Negative
here.
infinity.
So we want to go to the left.
It's wherever the back of that sign is.
Yep. We okay there?
Oh no.
Last one for notes here. For x minus 2y is greater than 6.
Wait, wouldn't you have to add your 4x to both sides, which you can't really do, so.
Well, we don't want to add 4x, so when we look at this to start with, is it in the correct format?
No.
No.
Solve
this
for y.
isn't in the correct format, so we need to solve for y.
So it'd be.
So what are we going to do first to solve this for y?
Subtract 4.
Subtract
on the other
4x.
side.
Oh,
So 2y is greater than.
Oh, hang on. What is?
-2.
-2y.
Divide
Okay, divide by what?
Divided by -2.
-2. Any thoughts about dividing by a -2? We have to flip the inequality. because we're dividing by a
That's
negative.
what I was thinking.
So this is an important piece here that I think sometimes is hard for students to understand. Sometimes teachers tell us fibs, and we've sort of been taught like, oh no, the information we're learning, you're really going to use that in the real world. Yeah, no, probably not yet. Okay, but we need all of these pieces to sort of come together so that we can get to the stuff that we'll use in the real world. So, right, we're pulling from these different, we're pulling from functions, we're pulling from inequalities, right? We're doing different things.
So wouldn't you graph -3 first?
So now we're going to graph in slope intercept form. So I'm going to start at -3,
Then you go up 2 and then right 1.
up 2/1, and I'm going to make a nice long line. Do I want that line to be solid, or do I want that line to be dashed?
Dashed. Because
Dashed, right? Because it does not have the or equal to. And do I want to shade above, or do I want to shade below?
You shaded above to the left.
We can't think
Oh.
left or right on this.
Below.
Remember, less than is lower. Less than is lower. So we want to shade below.
Below to the right.
So we would be shading this area here.